Hello, welcome to our today's session. Today, I want to show you something interesting, how you can maximize the value of your data using Jupyter Notebook. This is a Python editor under the Anaconda distribution, mostly used by data scientists and data analysts to manipulate data, do some data analysis and data visualization. Welcome and happy learning. So the first thing we're going to do, we'll import the libraries, the necessary libraries that you're going to use. So we import our libraries. So we will import two libraries which are crucial in data analysis. So we'll import NumPy as a NP. So this NumPy is for numeric computation. Then we have pandas. We import pandas as PD. Pandas is for data manipulation. Yes. So then we're gonna execute this cell. Next we're gonna create a variable called df, or you can give it another name suitable to your data set. So mostly people use this df since it's short, pronounceable, and straightforward. So I'll store my data in this variable called df, and I'll use pandas to read my data set. It's kind of loading your data set into the editor so that you can be able to use it. So I'll just copy paste the name of my data set from the directory I'm using, or the folder under the Jupyter Notebook. So I'm gonna copy paste the name of the data set, which is supermarket sales data, and we can go ahead and check the first few rows. Basically for data inspection, we want to get a feel of our data set. So df.head. So by default, this returns the first 5 rows in our data set. So let's view. And by the way, this data I've gotten it from Kaggle. You can, if you don't have a Kaggle account, you can sign up to Kaggle, and you can be getting downloading datasets for learning and practicing. So we have our dataset, the first few rows. Yeah, so we have the first column is for the invoice ID, and this invoice ID is computer generated. And before I move to the description of our columns, we have this data was collected in a supermarket located in the US from 3 branches in 3 cities from January 2019 up to February 2019. So we have the branches, we have 3 branches, A, B, and C. We have the city, which these branches are located in. We have the customer type, we have the gender, male or female. Product line, we have 7 product lines. We have health and beauty, we have electronic accessories, we have unit price in dollars, the quantity bought by a customer. We have taxation at 5%, the total amount paid, the date. The date consists of month, day, and the year. We start with the month, day, and the year. That's the format of our date column. Then the time the customer left the supermarket. Then we have the payment. We have 3 payment methods. We have the e-wallet, cash, and credit card. Then cost of goods sold. We have the gross margin percentage, gross income, and the rating. So the rating, these are customer rating, the branches, the ratings. So it ranges from 1 up to 10. So these are our customer giving the ratings. So we can go ahead and check the data types for each column. So df.info, we check the various data types present in our data set using the .info. Yeah, so this is a crucial part when it comes to data analysis, because you can be able to tell if you have any missing data in your data set. So we have this object here, pandas.co. This is a data frame. Yeah, and the data frame consists of rows and columns. Then we have the range index. We have 1,000 entries from 0. Python starts indexing from 0. So we have 0 to 999. Data columns, we have 17 columns. We have the invoice ID stored. We can see the null count. So we don't have any null values present in the invoice ID, and you can see is an object. The city, any text data in Python will be indicated as object. The city, the customer type, the gender, all these are text data, and they will be stored as objects. We have the unit price. We show something like 74.5, that's float. So any number containing decimal numbers that is referred as to us as floats. Quantity, that's an integer whole numbers for quantity. Taxation, we have float total, float date. We have time, payment, cost of goods sold, the rest. Then down here we have a summary of the data types. We have floats. Out of 17 columns, floats data types are 7. Integers, we have only 1 for the quantity. Objects, we have 9. Then the memory usage, we have 132.9. So this data have taken or used 132.9 KBs. Yeah, that's not a lot of memory used. Then we can check a sample. So we check a sample df.sample just to get a feel of what our data set entails. So you must specify the sample. So you can have 3 samples, 10 samples, 70 samples. Just indicate inside here if under the argument you can pass maybe can write a parameter. So 3 is a parameter. We want 3 rows, we want 8 rows, we want 9 rows. You can change. So we have this is a sample. It has been taken randomly from the data set, like that. We can check the summary statistic using the .describe for all numeric columns. So by default, the .describe returns summary statistics of all numeric columns. Yeah, so we have the all the numeric columns present in our data set. So we have the count, we have 1,000 rows, we have the mean, the standard deviation, the minimum amount for the unit price, the lower quartile, which is 25%, the median, which is 55, we have 77 for the upper quartile of the 75%. Then the maximum value for the unit price, we have 99.9. Then we have df.shape. We check the shape of our data set. How many rows do we have? How many columns do we have? So we have 1,000 rows. We start with the rows, then the columns. So the other thing we can do